Okay, let's look at section 2.7, graphing techniques. And the first technique we're going to look at is called stretching and shrinking. So I have example 1. In this example 1, I'm going to graph f of x equal x squared, which we already should know how to, and g of x is 2x squared, and h of x is 1/2 x squared. I want to graph them all on the same coordinate system. So let's look. I already did x squared, but let's come back to it. Let's remember that for x squared, the points were 0, 0, 1, 1, 2, and 4. And at the same time, negative 1, 1, negative 2, and 4. Now, let's graph g of x, which is 2x squared. Let's do it in red. Let's think together. So I'm trying to avoid tables, just like I told you. I don't want to use tables. If I use table, then what's the use? So I did red. Okay, and my red pen is not working. Let me try this one. Okay, if we look at the points that we know, when x is 0, y is 0, right? Let's look at it again here. When x is 0, this is just multiplied by 2. It's still going to be 0. So 0, 0 is a point. Now when x is 1, right? Now remember that g of x is my y. Okay? So when x is 1, y is twice what y is supposed to be. So the original points, okay, let me write them here. 0, 0. Let's do it in black. These are the original points as you know them. 1, 1, which are in all of the basic functions. In this one we have negative 1, 1, 2 and 4, and negative 2 and 4. So if you remember, that's my x and that's my y. So now for the second function, g of x equal 2x squared, when x is 0, y, just multiply every one by 2. So 2 times 0 again is 0. Now when x is 1, y is twice the amount of what is originally it should be. It should be 1, so now we're multiplying it by 2, so that is 2. So when x is 1, y is 2. When x is negative 1, y is 2 also. When x is 2, y multiply again. Each one of these is multiplied by 2, multiplied by 2, multiplied by 2 is 8, multiplied by 2, right? So when x is 2, y is 8. And when x is negative 2, y is also 8. So let's look at this parabola in red. Okay? Good. Then we'll have the conclusion. Let's do h of x equal 1/2. Let me make the same values that we remember, x and y. Again, we need 0. We have 0, 0. Hopefully you don't have to write them every time, but for now. 2 and 4, negative 2 and 4. Now, what we're saying is that each y is half of what is the original one. That's the original one. Each y is equal to 1/2 the original. Okay? 1/2 of what it's supposed to be. 1/2 x squared. That's the y is the 1/2. So x is still the same. So when x is 0, let's see. All this y is going to be multiplied by 1/2. So 0 still 0. 0 times anything is 0. When x is 1, instead of 1, it's 1 times 1/2. So it's 1/2. When x is negative 1, again multiply the 1 by 1/2. Now, when x is 2, instead of 4, again multiply the 4 by 1/2, it will be 2. So 2 and 2. When x is negative 2, it's negative 2 is positive 2 because the 4 is multiplied by half. Let's look at this parabola. So now we can have the conclusion, and the conclusion is, it's you can see it in your PowerPoints. Okay, you can write it from there because I'm not gonna write it all down for you, but I'm gonna say it so you can understand it. Now, when we multiply the function by a number that is greater than 1, then my graph is gonna be stretching vertically. See, I'm pulling it, vertically stretch. When I multiply it by a number that is between 0 and 1, meaning a fraction, then I'm gonna shrink it. And again, remember, as if this original parabola is made out of elastic material, then I'm gonna shrink it vertically, push it, so it's gonna get wider like that. Okay, stretching and shrinking. This is vertical, stretching and shrinking. It will be the opposite for horizontal. Okay, horizontally it will be the opposite, but let us just think of it as in vertically is better. Okay, now you can do all your examples for the stretching and shrinking. Remember the points. Each point is multiplied by whatever that number is. If it's 2, if it's 3, whatever it is. Let us actually do one without explaining too much. Let's do example 2 and see what we can. Here, this one without too much explanation. Let's say you're asked to graph f of x is equal to twice the square root of x. All right, so here is my coordinate system. All right, so remember the 3 points, 0, 0, 0, 0. Each y is multiplied by 2. So instead of 1 and 1, the y is multiplied by 2. So instead of 1 and 1, it's going to be 1 and 2. And the third point was 4 and 2, right? 4 and 2. But now each y multiplied by 2. So instead of 4 and 2, it's going to be 4 and 4. So the graph is going to look like that. Okay, I think that's enough.